Hey friends, today is Thursday. How are you? I hope that you're well because if you know what I know, then tomorrow is the last day before break, which is what makes Miss Trammell in a really good mood. So I hope that you are too. We have a couple of things to do today for Number Corner, and so I need you to be ready. Put your thinking caps on, make sure you're participating, you're listening because you are responsible for your own learning, okay? Today is December the 17th, and we are almost done with our December Number Corner for this month. So let's look at our Pentomino, which looks kind of like what we had on the 5th. So we see our pattern has repeated because I'll remind you that there are only 12 pentominos, not including the way that they're rotated. You can rotate them different ways and maybe they'll look a little different, but they're really the same. So pentomino has an area of 5 square units. Let's see how many sides it has. 1 side, 2, 3, 4, 5, 6, 7, 8 sides. So for today's shape, we have 5 square units. We have 8 sides, and let's see what our perimeter is. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So our perimeter is 12. Let's fill that in on our recording sheet. So, for December the 17th, and here we are. I said we had 8 sides, we have a perimeter of 12, and we have 5 square inches. 5 square inches. So I wonder then, how many lines of symmetry are in our shape? Let me remind you of what our shape looks like. Here it is. How many lines of symmetry? So a line of symmetry is an imaginary line. It can be a real line that divides a shape into 2 mirror images. So when you fold them, they will be exactly the same. Now, since the 17th marker looks just like the marker on the 5th, we could look at the 5th and see what we put, which was 0 lines of symmetry. But even if we didn't need to do that, hopefully you notice we can't fold it in half because of this little bad boy, this piece sticking up at the top. And we can't fold it horizontally this way because of the same deal. So there are no lines of symmetry here. How about parallel lines? Remember, they're going in the same direction, same distance apart. They're never going to intersect or cross over each other. How many would you say? Let's get a closer look of it. How many parallel lines? So this line is parallel to this line. So that's 1, 2, 3, 4. And then now we have parallel lines that are going horizontally. This will be parallel. So 5, 6, 7, 8. So maybe about 8 parallel lines. And how many perpendicular lines? How many corners? 1, 2, 3, 4, 5, 6, 7, 8 as well. So we can fill that in also. 8 parallel lines, 8 perpendicular lines. Boom, there it is. Now we're going to talk more about lines of symmetry today. Okay, so you may want to go ahead and pull out your Number Corner journal. And open it up. I believe it's page 41. It should look something like this. It should say symmetry at the top. Okay, I think it's page 41. And before we start working on it, again, to remind you of what symmetry is a line. It can be a real line because maybe you folded it and creased it and drew on it already. You're just imagining it because maybe you don't have the option to take a piece of paper and fold it to see if there are lines of symmetry. But what makes it a line of symmetry is that it's going to divide a shape so that both sides are the exact same. It is a mirror image, okay? That is what a line of symmetry is. And so, with that in mind, let's look at our problem number 1. Which of the following shapes have symmetry? So you may want to pause this video so you can work with a partner or talk about it, think about it, and identify your choice. Make sure you justify your thinking. All right, hopefully you've had a chance to pause this video. And now I would like to know, what did you choose? What shapes have lines of symmetry? Awesome, the circle does. Let's try that again, Ms. Trudeau. All right, the circle does. What else? Good, the triangle does. What is this shape? What do we call it? Parallelogram, yeah. And this shape? It's kind of like a trapezoid, right? Do these two shapes have any lines of symmetry? No. How about this triangle? Yes, it does. Did anybody notice, or maybe I should ask this question. How many lines of symmetry would you find in that circle? Anybody want to try counting? We could fold it in half this way. We could fold it in half this way. We could fold it this way. We could fold it this way. We could fold it anywhere on the circle, and that would be a line of symmetry. The circle has so many lines of symmetry. It's pretty cool when you think about it. How many lines of symmetry do you think this triangle has? Did you get 3? Here's 1. Here's 2. And here's 3. Yeah, 3 lines of symmetry. Now, what's really interesting is how many lines of symmetry does this triangle have? Does it also have 3 lines of symmetry? No, it doesn't. What's different about these 2 triangles? One we call an equilateral triangle, so the side lengths are all equal. And maybe that plays a role in determining how many lines of symmetry the triangle is going to have. This one, all the sides are not equal. It looks like 2 sides may be equal, but that's it. Good thinking. Let's look at number 2. Draw all the lines of symmetry on the shape below. Pause this video and see if you can figure it out. All right, how many did you get? Did anybody get anything different? Let's see. I know this would be a line of symmetry here between those 2 corners. And I guess I can make it go longer. I know this would be a line of symmetry here, those 2 corners. I can fold it down the middle. So far we have 3. I can fold it across the middle here. I can fold it at these 2 corners. I can fold it at these 2 corners. And I could even fold it in between those corners and in between these corners. How many lines of symmetry is that? I know it's a lot, right? It's about 8. So this line, 1, 2, 3, 4, 5, 6, 7, 8. 8 lines of symmetry. It's pretty cool too. Let's look at number 3, our last one for today. It says draw a line of symmetry for each figure. And when you do, I want you to see if you can notice any patterns. So again, you'll need to pause this video so you can work it out pretty quickly. Go for it. Okay, you ready? Let's talk about it. Let's review. How many lines of symmetry for the triangle? Same one that we did earlier, 3. So here's 1, here's 2, and here's 3. 3 lines of symmetry. How many for our square? 4 lines of symmetry. 1, 2, 3, and 4. How about for our pentagon? 1. How else can we fold it? You fold it like this. 2. Or is it like this? Yeah, we can fold it like this, which means we can also fold the other side like this. So that's 3. Can you find any other ways that you could fold it? Yeah, from this corner to this half, and from this corner to this half. So how many does that make? 1, 2, 3, 4, 5. Triangle had 3, square had 4, pentagon had 5. How about the hexagon? Let's see. 1, 2, 3, 4. What else? Yeah. 5 and 6. Awesome job. And now we have a 1, 2, 3, 4, 5, 6, 7-sided figure, which we could call a septagon. I wonder how many lines of symmetry you found on this one. Anybody see the pattern so far? So if the pattern is remaining true, then we have 7 sides. We should have 7 lines of symmetry. Let's check it out. 1, 2, 3. Did Mr. Mo make a mistake? I sure did. Let me fix that right now. Let's try this again. It would be 1. Here's 2. That makes more sense. From the halfway in between each corner to a corner. That's 3. And then from a corner to halfway would be 4. Another corner to halfway would be 5. We got 5 so far. 1, 2, 3, 4, 5. What else can we do? Right, we have another halfway mark in between 2 corners that can go to this corner. And halfway to this corner. So our pattern is holding true. Yes, and that is the number of, let me say it this way. Each shape has the same number of lines of symmetry as it has sides. Does that make sense? So the number of sides on the shape is telling us the number of lines of symmetry that are on that shape. Okay? That is the pattern that I noticed. I hope that you noticed the same thing. Now it says, what do you know about the figure that's going to come next? Oh wait, let's talk about this real quick. 3, 4, 5, 6, 7. But we had a triangle up here that didn't have 3. Does that say something to you? If not, I want to tell you that polygons, normal polygons, would probably follow this rule that we just, or the pattern that we just noticed. Okay? And maybe I shouldn't say normal. Maybe I should say regular polygons when all the sides are the same and the angles are the same. So if the angles are the same length, same degree, and the sides are the same length, then it's going to be a regular polygon and it's going to follow this pattern. And so knowing that, what's going to come next? Yes, most likely an octagon. With how many lines of symmetry do you think? With 8 lines of symmetry. You got it. Because it has 8 sides. And if it's a regular octagon, then it should definitely follow this pattern. Okay, very good. One last thing that I would like for us to do, which is to update our up and down to 2000, which now I'm going to say is just up and down to see where we are going to land by the end of December. So yesterday we ended up with 4,427. Let's figure out what we're going to get today. 4,427. Let's toss all three. And then I want you guys to practice using the standard algorithm to solve it. If you're struggling, it's okay. Use one of the strategies that we've talked about in terms of adding or subtracting. And it looks like this time we're subtracting. So less is what we got. And we have the digits 1, 5, and 4. So I'm going to add that here. 1, 5, 4. We finally get to subtract. So we're going to make the number 145. And let's subtract 4,427 minus 145. 4,427. We are subtracting 145. Let's make it happen. Okay, hopefully you pause so you can solve it on your own. And if not, we're going to talk through it really quickly. And then we're done for today. 7 minus 5. We can do that. Then let me get the right pen. 7 minus 5 is 2. Okay, we have 2 tens and we're trying to take 4 tens away. Can we do that? Absolutely not. Kind of like having 2 dimes and we need to take 4 dimes away, but we don't have 4 dimes. So we're going to break our dollar up into dimes. So I'm going to take one of my dollars and I'm going to get change for it. So it gives me $3 now. Then I'm adding 10 more dimes to the 2 dimes that I have. Now I can take 4 dimes away, which is going to give me 8 dimes. 300 minus 100 is 200. And then 4 minus nothing is just 4. So our new number is 4,228. We are still well over 2,000. So we've done a really good job this month. You guys have a great afternoon. I'll see you again tomorrow for our last day of December Number Corner. Bye-bye.